Hello and a big welcome back to all my subscribers. And if you're not a subscriber, why not? What's wrong with you? Right, today is a continuation of the series on RISC-V programming in assembler for beginners. So I'm just going to get into this today. Today we're going to cover looping, so for statements, if statements, while statements, that sort of thing in a higher level languages. But how do you do it in assembly language? And more specifically, how do you do it in RISC assembly language programming? So let me just quickly shoot over to the source code that I'm going to show you today. Now, the assembly language does branch on equal, etc. It doesn't do for statements or loop statements or anything like that. You kind of have to create them yourself. So basically what happens is you can compare registers and you branch if they're equal, branch if they're not equal, branch if one is less than the other, branch if it's greater than, less than or equal to. Those are the standard branch statements that you can use, but you can also use other things which are jump statements, which are just jump directly to a label. Now, in this program, we do section text, which is basically the code, and we're saying that main is the global entry point for this. All we do is we load some initial values into some registers. Then I'm going to show you how to do a for loop, how to do an if statement, and then how to do a while statement. Now, technically, this is a do while since it does one iteration at least, but you know, it's easy enough to change. So let's just leave out of here and we will just do Emacs and go into GDB. And it will run the compiled code. I've already compiled it, so I don't need to do that. I'm going to set a breakpoint at main and then run. And you can see below the code, and we are at the first one where we are loading values into A0, then A1, A2, T1, T2. So if we just look at those values quickly, sorry, and it's a T1 and then T2, you can see that we've loaded those correctly in. Now, I've got a label here called for loop, and the first thing it's going to do is increment the A0 register. Now, rather than me type it in all the time on GDB, I'm just going to make it display A0 when it changes. It's currently set to 1, so when we step and we do add integer to A1, it changes to 2 as you would expect. And then we're doing branch greater than or equal to. So we're going to branch to the for loop end label if A0 is greater than or equal to 10. It isn't, so it passes through. So here in this for loop, the logic is kind of slightly different than you would get in a C. So it's comparing it to see if we've actually reached the end of the for loop, and if not, it's just going to jump back to the label, which is the start of the for loop, and then go to the next instruction, which is again the add instruction. Now, if you look up here in the GDB thing, you will see that as we're stepping through this, it is just going to increment the values as we go along. So we'll just swiftly go through this until we get to 9, and then we'll walk through it. Here it's 9, and it's going to jump back to the for loop. It's going to add 1, and you can now see it's 10. So now it's going to do the comparison, and it will actually register the fact that it is equal to or greater than 10, and it will go to the for loop end, which is down here. You notice that there's nothing in this statement because for me, I'm just going to end this loop, really, and nothing else need happen. And then we move to the next instruction, which is inside the if statement. Now, again, these are just labels. You can call them whatever you want. I've just decided to call them, for the sake of this demonstration, if and for and that sort of thing. Now here, if you remember from our last video, this is a shift left instruction. Now we know that the A register is currently equal to 10. So when we shift left, you can see that it's 20. If you remember from the last video, a shift left is effectively multiplying by 2, because in binary what you're doing is you get these numbers and you're basically shifting this number over 1. You're shifting that number over 1, which is effectively multiplying by 2. Now, what it's going to do here in this if statement, it's going to check two conditions. It's going to check if A1 is less than big number, or small number. Now let's just remind ourselves that T2 is set to 99. So it's going to branch if A0 is less than 99. It is. So it's going to jump to small number. So you can see that it's completely skipped over this check. It didn't bother because it has already matched this condition, so it just went straight there. Now all we're going to do is just load back to, we're going to set A0 back to 1. And then it's going to jump. So just J it's not conditional. It's just going to jump down to this while label. Now the reason that is because we want it to jump over big number. We don't ever, it didn't hit that condition, and we don't ever want it to go into this, so we just have to jump over it. So that's what we're going to do. We're going to jump over that, and we then go into the while. Here we're going to be manipulating A2. And so I can do display $A2, and it's currently 1. Just to remind ourselves that we did load A0, A2, and T1 are the values that we're going to do in this for loop, and they are currently set to 1, 1, and 10. So it's going to add 1 and store it in A2. So now A2 is 2 rather than 1. It's going to branch if less than. So here it's going to check as A2 less than T1. And you can see that T1 is 10. So yes, it's going to branch back to the while label. Now, remember I said this is a do while rather than just a while. It's a do while because it did actually increment something at least once. If these two statements were reversed, if you checked before you did the increment, then it would be a while statement, because you don't actually check. You don't actually increment or do anything. You just check, and then if it's true, then you exit. So, but we will step through this, and as you can see, have you spotted the problem? Now, this is not a deliberate fault, but it is a good example of where you can go wrong in assembly language. Now, what we're doing here is we're adding we're storing in A2 the addition of 1 to A0. But A0, if we look at A0, is 1 every time. We never change it, right? So it doesn't matter how many times we run this, it's never going to change. And we have effectively created an infinite loop. This is never going to stop, because the thing we're checking, A2, never, ever, ever is going to hit the value of 10. Because we're basically taking 1 and 1 and adding up to 2 and storing it in A2 every time. So A2 will always be the number 2. It is never going to reach 10, and this is an infinite loop. So that's it. So we're never going to hit exit. This is basically an infinite loop, and it's gone horribly, horribly wrong. So to fix this problem, realistically, what we should be doing, or should have done, is increment A2 by 1. Then at that point, this will work. So if we now go back and make this again, and then run this again, but this time I'm just going to break in the while. I'm gonna skip over all that other stuff, and then just run. And you can see that I'm already in the while loop here. And so if we check A0, A2, and T1, these are the values as we enter the loop. We step, and let me just display $A2 so that we see this all the time. And it's a 2, and we step, and it's a 2, and now it's a 3. So you can see that we're now incrementing A2. So A2 is now incrementing, and it will eventually reach 10. And now it's going to fall through to the jump to exit. And we're just going to make the system call to quit the program. So it's just, it wasn't intentional, but there you go. Things do happen in programming. Now, if you like this sort of content, please let me know. Please like and subscribe and all that good stuff. And, you know, I'll continue to make these types of programs. I think the next time, I don't really know what I'm going to talk about, but I will probably introduce not system calls, but calls to the C library. So things like printf, you know, fgets, things like that. So you can get user input, you can print out input. I mean, at the moment, all we've done is just use the debugger to look at the values. But, you know, next time we'll look at doing some print statements or call to the C library that lets you, you know, interact with the user and the standard C library. Right, that's it for today. Thank you very much for your kind attention, and I hope you have a lovely rest of your day. Bye from me.